So that wraps up our material for user-defined functions. In this video, we're going to do a summary. So UDFs are functions that you create. Functions execute a block of code each time they are called. So whenever we reference a function by its name and call it, it will execute all of that code in its code block. So functions are great for calling the same code over and over again without having to rewrite it. All right, so here is the general structure of a function. You have to use the def keyword and then some function name, and then you must have parentheses. If there are any parameters in here, you separate them by commas. You have to end the line with a colon, and then when you press enter, the editor will know that it'll indent, and so there'll be some code block, and that's what gets executed every time the function is run. Whenever the code block indentation returns back to where it started, then that will just be outside of the function. All right, so we can have functions that have an explicit return keyword. So if you don't have a return keyword, then the object none is returned. So here's a function that returns this variable total, which is just a sum of two dice rolls. You can define functions with parameters. So you just separate them by commas, and then otherwise the function is the same. So we had this discussion on what is a difference between parameter and argument. So parameters are the variable names in the function signature. They take on the arguments, which are the values passed to the function. So for instance, down here, these are the arguments, 512, 0.01 and 20. The parameters we can't see here because this is passed as positional, but we have max error and guess. So those are the differences between those two. So we called functions in different ways using positional and keyword arguments. So positional, this is where we don't have the parameter name in the function call. The argument just aligns with whatever the function was however it was created. And here for square root, it was num was the first one, so 512 would be equal to none. For the keyword arguments, they don't have to be in particular order because they're not positional. So whatever you assign it like this, that's what the argument, or that's what the keyword parameter will be. So there's certain rules over here. You can't have positional arguments that follow keyword arguments. All right, now then we learned about how to define functions with positional only and keyword only arguments. So using the / and the asterisk. So if you use a / in the function signature, that means all the arguments that come before it are positional only. So in this case right here, it is A and B. With an asterisk, all the arguments that come after it are keyword only. The ones in the middle will be either keyword or positional. We then learned how to document our functions using docstrings. This is a very important thing to do. This is a triple quoted string directly below the function signature. We learned about the NumPy docstring standard with the different sections. I recommended using the parameter section and the return section at a minimum. We then learned how functions are objects, just like every other object we've learned about, integers, floats, lists, and so on. They have a type ID, they have attributes and methods. You can pass them to functions, you can return them to functions, you can assign them to variables. So they just operate the same way as all the other objects that we learned. The only real difference is that you can call them, and that's what makes them functions. We learned that some built-in functions on the Python official documentation are actually types, like bool, int, and float. We then learned how to create anonymous functions. So these are simple one-line functions. They use the keyword lambda instead of def. There is no name, as we can see an example over here. The parameters are still separated by commas, but there's no parentheses. There is a colon, and then there is no return statement. It is just the body of the function like that, and that's what gets returned. So we typically use anonymous functions to pass them in as function arguments. So we saw that when we wanted to sort by the second letter, and the key parameter for the sorted method accepted a function, and so this was a good time to pass that in. Map and filter are also good use cases for anonymous functions where you passed in the first argument as a function, and usually it's just going to be a simple function. So that's where we can use a lambda instead of formally writing out a function using def. But then we found out that these are both reproducible using list comprehensions. so they're not all that useful, and I suggested to use list comprehensions over map and filter. Finally, we learned some rules of thumb about functions. Most of your code will appear in functions, and we will see that in almost all of our upcoming, really in all of our upcoming projects, we will be using functions for everything. Functions, when you write one, it should complete one task, it should do it well, and then you should break it up into multiple functions if it's too long or complex. All right, so that is a summary of user-defined functions.